Hello, everyone, and welcome to ScienceholicMagazine 2023 webinar, A Journey into the World of Chemistry. Thank you so much for your interest today in atmospheric chemistry, and we are so excited to welcome Professor Anastasio to talk about his experience in atmospheric chemistry and pollution. My name is Jessica, and I will be hosting today's webinar, and Sabrina will be the co-host. She will be helping out in the chat. And before we get started, I would like to give a brief introduction of what ScienceHolic is. We are a youth-run nonprofit that aims to introduce intricate scientific topics in a manner that is fun and comprehensible to teenagers, because we realize that a lot of different scientific topics can be challenging and hard to understand. We also provide volunteering and leadership opportunities to teens globally. And we also extend this opportunity to people who has English as their second language. And we also actually publish seasonal magazines as well. And with that, we translate it into Chinese as well for those who have Chinese as their main language. Our main mission is to serve as a free resource for students to learn about various STEM topics. And through that, we publish, as I say, seasonal magazines, and our most recent one was actually published in April. It's a biology themed one, and it was our 7th edition. You can check it out more on our website later on after this webinar. And without further ado, let's welcome Professor Anastasio again. Professor, would you like to introduce yourself?
Sure. Thank you, Jessica. Thanks to Jessica and Sabrina for organizing this, and to Leah and Jasmine for being here. And sorry, also Angela. So first of all, if you're listening on the recording and not live, you missed a very interesting turtle discussion. So I encourage you to attend these things in person to not miss pet discussion. So my name is Cort Anastasio. I'm a professor at the University of California, Davis, and I study the chemistry of the atmosphere. Specifically, I study particles in the atmosphere and drops in the atmosphere, so like cloud and fog drops. So my group and I are really interested in reactions that happen in the particles and the drops that are floating around in the atmosphere, and how those reactions might affect human health, or how they might affect climate, or how they might affect the cycling of different elements in the Earth system. We study photochemistry, and photochemistry just means chemistry that's initiated by light. So if you're going to study chemistry in the atmosphere, the sun is a big source of energy. And so the sun drives lots of chemical reactions, and that's what my group studies. I did my undergraduate degree in chemistry. I went to Brown University. And then I worked for a couple of years. I taught high school, and then I worked in an analytical lab doing water testing. And then I went back to graduate school and got my PhD in atmospheric chemistry from Duke. And then after I did that, I did what's called a postdoc. So it's several years of study after your doctoral degree. And this is pretty common in my field if you want to be a professor. So I studied for a year and a half at York University in Toronto, and then I came to Davis. Next slide, please.
Yes, thank you for your introduction. And attendees, if you have any questions, please put your questions in the chat. I will answer them at the end of this webinar. All right, without further ado, I'm gonna start asking questions. So our first section is academics. So how did you choose your major, and what sparked your interest in atmospheric chemistry?
So I had a great high school chemistry teacher, and she got me interested in chemistry. She actually just passed away a couple of years ago, unfortunately. But she was a great teacher, and I thought the field of chemistry was amazing because you could understand kind of macroscopic phenomena from a microscopic level. So understanding what these molecules were doing, molecule to molecule, could help you explain something that was very interesting, some chemical reaction or whatever it was. So I started as just a chemistry major. Well, I was a chemistry major in undergrad, and I knew I wanted to do something in environmental chemistry because I've always been very concerned about the environment and always have wanted to try to help the environment. And so when I was looking at grad schools, I looked at all sorts of environmental chemistry grad schools. Some were air or atmospheric chemistry, some were water chemistry, some were soils, some were biological chemistry. So I looked at all sorts of different areas. And I chose atmospheric chemistry because there was a professor at Duke who was studying reactions in cloud drops related to acid rain. And I thought that sounded pretty cool. So I decided to go into atmospheric chemistry.
That sounds awesome. I feel like, yeah, I feel like teachers play like a huge role in our lives when we decide like what career you want to choose from. Because I also had a similar experience. I'm also planning on doing a major in chemistry. I just don't know which like field yet. But it
Yeah.
was also because I had a great like chemistry teacher and we like talked a lot and I just found like my passion through them.
Yeah,
So,
that's great.
mhm. So our next question is, what are some of the most interesting classes you took in undergrad slash grad school? I feel like in atmospheric chemistry, there could be like maybe some really interesting classes that are only specific to your major. Would you mind sharing some of those classes?
Yeah, so as an undergrad, I was just straight chemistry because we didn't have any environmental chemistry at Brown. So I just took the normal chemistry track. Um, but one of the great things about Brown was there was a lot of flexibility in the courses you could take. So even though I was a chemistry major, I took art, studio art, I took African history, I took philosophy, and I really enjoyed my chemistry classes, but it was also nice to take classes that weren't chemistry sometimes because the chemistry gets a little intense. Um, then when I went to grad school and studied environmental chemistry and atmospheric chemistry, that's where I got to finally take classes that married environmental work and chemistry. And so those were great to explain, why do we have air pollution? Why is the sky orange after a forest fire? How do you make smog? Why is the ozone layer, why was it being destroyed? What's happening with climate change? So it was really nice to take atmospheric chemistry classes and learn all about all these really big problems we have related to air pollution and climate change.
Yeah, I'm glad that you took a class that like talks about such a, I guess, such conflict that we have right now because climate change and air pollution, like you've seen it happening like I guess like 2, 3 months ago with like the California fires and everything like that. So I feel like it's great that you're trying to learn about it and try to, I guess, lessen air pollution and trying to kind of revert climate change. Because this summer was also one of the hottest summers that we had, which I thought was really crazy.
Yeah, July was the hottest month on record
Yeah, it
globally.
was it was so hot. I was so glad I stayed indoors.
Yeah,
Texas reaches 100 Fahrenheit like every day, so it's hard to go outside under that.
yeah,
Yeah, it's
yeah,
becoming
it's a
such
big
a
problem.
it's a big problem. All right, so our next question is, what are some hardships you had to overcome to become a professor? Because I understand that, getting a PhD requires so much work, so much patience, and we want to know like what are some challenges that you had and how did you overcome them?
Yeah, PhD is definitely a lot of work, but the great thing about a PhD is if you get a PhD, hopefully it's in an area that you're passionate about. So it is a huge amount of work, but because I loved it, I loved what I was doing. I was really interested in trying to find the answers to the questions we were asking. It didn't feel like drudgery. It felt like, I get to go into the lab and explore and do experiments and try to discover new things. Because as a PhD, you're going to be doing research in an area that other people maybe haven't done. And so you're going to make new discoveries. And it's like being a detective. And so it's a lot of work, definitely. And it's challenging and there are hard parts to it. But it's if you're into it, and you shouldn't do a PhD unless you're into it. If you're into it, it's really very rewarding. Yeah, and then becoming a professor. Well, being a professor is in the beginning when you don't have tenure. It's also a lot of work. So when I was an assistant professor, it's like constant work until you get tenure. So that's challenging as well, although that's changing now too. I think there's a lot of discussion about work-life balance at universities. And so I think the expectation is that you're not going to kill yourself to get tenure anymore. You're just going to work very hard and hopefully be successful.
How long did it take for you to get your PhD?
It took me a little more than 4 years,
Okay.
which is fast. It's more typical, I'd say 5 years.
Okay.
But yeah.
Yeah, PSA everyone, make sure to take care of your mental health when doing like a PhD or just going into any like undergrad and graduate degrees, because it does get kind of hard and like overwhelming sometimes.
Yeah, 100%. And you can't work all the time. And that was something I had to learn. You got to take care of yourself. You got to do things that you love outside of work. So, hopefully you've got some hobbies, or you've got some turtle pets, something where you can spend time that, gets you some downtime and spend time with your friends. So yeah, you don't want to work all the time. That's not a life.
Mhm. All right, so that was our first section of questions. Our second set of questions will focus mainly on your career. And so you said that you've been teaching at UC Davis for over 27 years. What do you think was your biggest accomplishment during that time? And was there any publications that you're really proud of?
Yeah, so on the teaching side, a couple things I'm most proud of is I've developed 3 or 4 classes at Davis. So I developed the first class in atmospheric chemistry at Davis. I developed a class on climate change. Well, it existed before me, and then the professor who was teaching it retired. But it had been taught as just a very small seminar class, like 8 people. And so I made it into a full-blown lecture class, and now I've got like 120 people every year who take this climate change class. And so I'm very proud of being able to teach, this generation about what do we know about climate change, what still don't we know, and how can we solve it. So that's the teaching side. The research side, my group studies, as I mentioned, reactions in particles and drops in the atmosphere. And specifically, we look at what are called oxidants. So you guys probably are familiar with the oxidants maybe in the body and antioxidants. So an oxidant is just a molecule that wants to steal an electron from another molecule. And in the body, that's a bad thing, because if a molecule loses an electron, it'll often lose its function in the body. In the atmosphere, this oxidation process is the way that the atmosphere cleans itself. So we emit a pollutant, and then an oxidant in the atmosphere will react with it and make it into some kind of water-soluble product, and then rain will wash it out of the atmosphere. And so my group has done a lot of work measuring oxidants in particles and drops in the atmosphere, which helps our understanding of like the lifetimes of pollutants in the atmosphere, and also, how long will different chemicals live, and what might they form when they get reacted away. So that's probably kind of that set of publications is something I'm very proud of.
Is there any, I guess, ongoing research about maybe making like artificial oxidants to release into the air? Like, will that like work to help reduce pollution, or is that just like a natural thing?
Yeah, interesting question. So a lot of the reactions that make oxidants are kind of natural background processes. There has been discussion of adding different things to the atmosphere to try to speed up the process. I would say in general, adding things to the atmosphere or to the environment overall is generally a bad idea, because the environment is so complicated that you think you might understand what will happen when you introduce this chemical, but there are often surprises. And so, for example, the ozone hole and the destruction of stratospheric ozone, that's an example of where humans manufactured chlorofluorocarbons, which were great chemicals for their intended use. They're used in refrigerators and air conditioners. Well, they used to be, they're banned now. But what we didn't understand is there was no oxidant in the troposphere. So the troposphere is the bottom of the atmosphere where we live. In the troposphere, there's no oxidant that can react with CFCs. And so they went up through the troposphere into the stratosphere, and in the stratosphere, they were broken down by the very high energy sunlight. But in that process, they destroyed ozone. So it's an interesting question. Can you add something to speed things up? But I think it's always a little dangerous to mess with Mother Nature.
Yeah, that is true. Yeah, I don't feel like if we sometimes like accidentally add something into the environment and it reacted differently, I feel like we might worsen air pollution somehow.
Yeah, right. It's definitely a possibility.
Okay, let's see. Our next question is, how does your daily go-to schedule look like?
So I have a 15-year-old son who's in high school. So wake up, make breakfast for the family, get the son off. He bikes to school, fortunately. And then usually I'll start to have meetings in the morning. So I have, I think, 5 people in my research group right now. So grad students and postdocs and research scientists. And so often in the morning, I'll have a couple meetings with some of the people who work with me, and we'll talk about their research and what did they do this past week, because we'll meet every week. So they'll tell me what did they do in the lab, and what did they find, and what worked and what didn't work, and what are their plans for the next week. And then on days when I teach, I'll spend some time preparing for class, and then I'll go to my class, and often I'll have office hours to meet with students and ask, have them ask me their questions. And then I try to do, I've got, some things that I do on my own, like I've got some papers I'm working on. So I try to carve out some time that I can do some writing on my own. Yeah, so that's it. That one of the nice things about being a professor is like every day is different. And so sometimes I'll do more research, sometimes I'll do more teaching, and I've got a bunch of different research projects going on. So I get to interact with lots of other people to think about research. Yeah, so that's mostly what my kind of vague day looks like.
You mentioned before in our previous question that you think like work-life balance is really important. And on that topic, do you have any hobbies that you like to do throughout the day, or like anything you do for like leisure time?
Yeah, good question. So I showed you my dog earlier. We got him during the pandemic, and he loves to take walks. And so it's nice, like during the middle of the day, sometimes I'll take him out for a walk if it's not too hot. I also, in Davis, we have a mountain biking team for middle schooler and high schoolers. So I'm one of the coaches on the mountain biking team. So we'll go out twice a week and go mountain biking in Davis or in the surroundings. And then my son plays soccer. So like today we went to one of my son's soccer games in town. Yeah, so got lots of things going on that are outside of work that are a nice break.
Yeah, those all sound like really fun activities that you get to do with your your friends and your family, and especially with your dog. So I think
Yeah.
that's really balanced. Um, let's see. Our third question is, what was your favorite part about working at UC Davis?
Okay, so first, that's not UC Davis, is it, in the picture?
That's what Google showed me.
Oh,
So
is
I've
it?
actually never been to California. So I can't even guarantee. That's what just Google showed me.
Oh, is it? Okay, but it looks more urbanized than I think of our campus. Second, I'm still working at UC Davis. So what is my favorite part about working at UC Davis? That's a good question. I love doing research with my students. I love talking to them about their research and what they found. Again, being the detective. But the best thing about being a professor, at least for me, is I get to do all the detective work, but I don't have to actually do the work. The students can do the work. They can make the discoveries, and then they can come back and tell me about the amazing things that they found. And then I get to bask in their glory. So that's one favorite thing. The other favorite thing is I really enjoy teaching because the students have a lot of energy. And especially in the climate change class, there's a lot of desire on the part of students to try to fix this problem. And students are really into it. And it's great to talk to them about it and what can we do about it. So I love the energy that the students bring in classes.
So I'm actually gonna take an introduction to climate change class as well this semester. So
Oh, that's great.
yes, I'm actually hearing about you talking about these advocates who are trying their best to, help resolve this issue of climate change is actually getting me excited because I'm
Yeah.
hoping that that's like the same environment that I will be in once I join the class. So I'm hoping
Yeah,
that's
I
how it
find
goes.
the people in the climate change class are the most passionate students that I have. So it's great energy. And man, what young people now are doing such important things related to climate change.
Hmm.
You guys heard about this lawsuit in Montana that students brought? So
Actually, no.
it's a bunch of students, I think they're aged like 10 to 15. The Montana Constitution, state constitution, says something about that the state will provide a healthy environment. And so these students were suing the state because the state wasn't taking into account the impacts of the climate change impacts of oil and gas development. And so a lot of people thought this lawsuit was going to get tossed out, but it's moving forward now. So it's pretty exciting that these young people are like the face of change, and not just in Montana, all over the US and all over the world. So young people, you guys can do it.
Yeah, it's for our future. And I actually, damn, 10 to 15 years old, those are some really young advocates trying to help resolve
Yeah,
climate change. That is really inspiring.
yeah, it's great.
Um, our next question is, out of all the courses you teach, which course is your most favorite?
Yeah, that would be the climate change class. Yeah,
That's reasonable.
yeah,
I can
lots of
see.
energy, lots of enthusiasm.
Is there like a least favorite class, or do you just like all your classes equally?
Jessica, do you have a least favorite turtle?
Okay, now thinking
No,
about it,
you love them
uh,
both, right?
yes, I do love them both.
Even the little vicious one.
That one's my favorite. That one's actually mine.
Oh,
So,
that's your favorite. Okay, nice. Yeah, so I don't have a least favorite class. I like all the classes I teach.
okay. Yeah, I think it's good that you're teaching all the classes that you like because it wouldn't be that fun to teach a class that you don't like. So
I mean,
it's
that is a good
reasonable.
point, and that definitely happens. People get in classes where they don't really like, and yeah, that's difficult. It makes it a lot more work and a lot less fun.
Mm. Okay. So we're on to our last question. So what are some advice that you would give to students that are interested in STEM? And like it can be advice that you wish you were told sooner as well.
Yeah, good question. I think one advice I would give to college students in general is don't feel like you have to be on this straight and narrow path and come in at a certain major and crank through that major and finish. College is really a time to explore. And so when you get to college, try different things. And, hopefully college is going to set you up for a career. But you don't want to be doing something that you don't love. And so in college, if you're STEM or not STEM, try different things, try different STEM fields, just see what's out there and try things and see what you love. Don't feel like you have to major in this or that. You should major in the thing that you really want to do. The other thing is, in terms of STEM, it can be hard, right? It's a lot of STEM is very technical and pretty difficult. And so even in high school, try to get help. When you need help, try to get help. And so, especially in college, seek out your teaching assistants, seek out your professors, ask them questions, try to develop a relationship with people. And, this is important for high school and college. Because if you don't understand something, don't be ashamed of that or don't think that's your fault. Just try to understand what's going on. And so talk to people and try to get help. I think that's we have office hours in college where I'll be in my office and I'll wait for people to come by and ask me questions. And some students are really good about coming to office hours and talking about the material and getting to understand what's going on. And other people I'll never see in office hours. And I think that's too bad because they're missing out on something that would help them. And, college is expensive, so you should get your money's worth. So I guess go to office hours. That's my one of my big pieces of advice.
Yeah. Don't hesitate to reach out to your professors, because I feel like a lot of people think like they're intimidated by like the professors and teachers.
Yeah.
And I feel like you shouldn't, because at the end of the day, they're still human and they're here to help you. So
right, I agree. Now, are some teachers and professors jerks? Yes.
sometimes, yes.
It happens, right? And so, okay, so in that case, maybe you don't want to go to that person. But, I would say try, and then maybe it'll work. And if it doesn't work, try to find some other resource.
Mm-hmm. All right. Thank you everyone who has attended. If you have any questions, please send them in the chat now and we can answer them. We'll give it a minute.
Okay, while we're waiting. So Sabrina, are you also in New York?
No, I'm in Hong Kong right now.
Whoa, you're in Hong Kong. Wow.
Yeah.
And what time is it in Hong Kong right now?
9:07 a.m.
Oh, okay. So not too bad. That's good. Yeah. And Jessica, did you enjoy the Canadian wildfire smoke this summer in New York?
Oh my God, let's not. It was so bad. My school had to close down for like 2 days.
Yeah.
Like I was in school and I just see like the sky turn like orange. It was so weird.
Yeah. Yeah, usually that's a West Coast thing. So it's scary that now it's happening on the East Coast too.
Yeah, I didn't expect it to come all the way here to New York, but I guess it did.
Yeah.
All right. If we don't have any questions, it seems like, yes, we have a question from Leah. And her question is, could you elaborate more on climate change classes, like research, projects, etc.?
Sure. Good question, Leah. So the climate change class that I teach, it's based on a book called Introduction to Modern Climate Change by Andrew Dessler, who's a professor at Texas A&M. It's a really good book. It's even, if you're STEM minded, you could definitely read it in high school, and I think you get quite a bit out of it. So I follow the book pretty closely, and he talks about kind of in the beginning about energy from the sun and what determines the Earth's climate, like what's the natural climate on Earth, what are all the different parts of the climate system, and then how have human emissions of greenhouse gases changed the energy balance and therefore changed the Earth's climate. But then he'll also go into, what do we expect to happen in the future? And it's actually interesting for climate change. It's always changing what we understand, especially in terms of what the expectations are for the future. So for this class, it's always keeping me on my toes because I always have to look at the latest predictions for what we think is going to happen. And then in the book, he also talks about, okay, so how do you solve climate change? What is it going to take? How can you both prepare for the changes in climate that have already happened and that will continue to happen, while at the same time trying to reduce the emissions that are causing climate change? And then I'll also, in the class, spend a little bit of time in each lecture about essentially a current event in climate change. So like this, I was just telling you about this Montana lawsuit brought by school kids. That would be the kind of topic I'd cover, and we'd talk about it in class, like, how does this make you feel? And do you guys think you could do something like this? Or so it's nice to bring it to things that are happening like right now. So we'll talk, for example, about wildfires on the East Coast or in the West Coast. And, we've had a lot of bad wildfire years in the last several years in the West Coast. And so that's something that people have lived through and they have some experience with. And, climate change touches on so many things that we do. From it being too hot in the summer to not being able to breathe when it's smoky. And so you're seeing more and more of these impacts from climate change. And so we'll talk about that in the class. And yeah, it's just a very interesting topic because it cuts across so many areas, from science to economics to politics. So I definitely encourage you all, if you've got an opportunity to take a class on climate change, I would definitely encourage you to do that.
Thank you so much. And I think climate change is a very interesting class. But also I think recently there's a very big wildfire in Hawaii. It's on the Maui, I'm not sure how to pronounce, Maui Island, and it's like some people think it's on purpose, like some people set the fire, but there's different reasons to it.
Yeah, I think for any disaster like that, there's kind of a natural component, but there's also things are generally made worse by climate change. So like the winds, those high winds that they had, that's probably linked to climate change. And Hawaii's suffered through some drought, which is very uncommon for Hawaii. And so that's probably linked in part to climate change. So yeah, it's incredible, right? I mean, the news this summer, there are just so many events that are linked to climate change. You guys probably heard that the ocean is the hottest it's ever been. The waters off of Florida were over 100 degrees. That is definitely linked to climate change. And that's going to lead to more, probably bigger hurricanes this coming hurricane season. So there are a lot of impacts. I see that Jasmine wrote in the chat, do I actively participate in any organizations helping the earth in any way? That's a good question. We do. On the Davis campus, we have an organization of students and faculty that's called Fossil Free UCD. UCD is UC Davis. So a group of us are lobbying the administration to try to stop using fossil fuels. And so we've been working over the last several years with campus to try to encourage them to move to renewable energy sources, solar, mostly solar, actually. So that's the one group where I'm putting my time in. And then I have a number of environmental organizations that I give money to support their work related to climate change.
Thank you for your response. So do you personally use solar panels then?
I do. I put solar panels on my house about 12 years ago. And the next thing I'm going to do, and I've just been slow to do it, is I'm trying to electrify my entire house. So you guys, maybe you know, maybe you don't know how your house is heated, how your house is, what your stove is, whether it's gas. So in my house, our hot water is natural gas. Okay, now natural gas is not natural. It's a fossil fuel. And so when you burn natural gas, you make carbon dioxide. And so I'm trying to get, well, I need to do it. I need to get an electric water heater. So get rid of gas there. And then I also want to get a heat pump because we have a gas furnace to heat in the winter. So I'm trying to completely electrify our house. And then hopefully we can run all of it off the solar panels. And so our house will have very few greenhouse gas emissions.
Oh, I see. Thank you.
Yeah, you're welcome, Jasmine.
It seems like those are all the questions that we have. So this is the end of our webinar. So these are our social medias. So please give us a follow if you're interested, and we'll be posting this conference on our YouTube and on our website. So the links will be posted in the chat. And attendees, if you are interested in working with us, like through volunteering or becoming an ambassador, here are some various ways you can do so. We have 6 teams total, and I am a part of the outreach team. You can also submit articles that you wish to be published, and yeah, please join our mailing list for more updates on new articles and new magazine releases, and other webinars like this. We host this once a year, like a week-long webinar. And yeah, thank you for attending. This is actually our last webinar for this whole conference, so I'm glad that you guys were able to make it today. And we'll be posting Professor Anastasio's email into the group chat if you need it. Feel free to email him with more private questions. And yeah, once again, thank you for coming. And yeah, I hope to see you guys in our next webinar. Thank you.